I want to go ahead and close out the California Housing Notebook now by looking at a different scoring metric. Go ahead and open your model from before. By the way, if you're ever in a scenario where like these didn't have anything on them, like, oh no, like maybe they got timed out, just go to runtime and like run all. Sometimes I like to keep my numbers the same, so you can do restart and run all, and then it's going to start over from one instead of, otherwise it'll just keep going, and these will be like the 20th cell instead of the 10th. So you can always do that, by the way. Restart and run all, yes. Do that whenever you're copying notebooks as well. And it's going to go top to bottom, and your Colab notebook should always run top to bottom as well. So what we're going to do now, and put in a subheader, do this with me, add a text, double hashtag for subheader. We're going to look at the root mean squared error. This is actually the standard error metric in linear regression. So how do we get it? Well, let's just do another regressor for the fun of it. Let's do the, let's say we're going to build and score XGBoost model using the root mean squared error. Okay, so how do we do that? Well, you got to get XGBoost in there. Like, what is he doing? XGBoost in linear regression. Well, this is a different regressor. Okay, it's a bunch of decision trees. It learns from the errors. So it's from XGBoost, import XGB regressor. I'm putting this in here because this is probably the best default models that you can use for tabular data before machine learning. Now we can go ahead and fit it if we want, right? We've already got the data in here, so we can do model equals XGB regressor. And then we want to do model dot fit it on X and Y. Now, when you're doing a different scoring metric, here's kind of the way you normally do it. You get some predictions, Y prediction equals model dot predict, and we want to put in there X test, which I already have. So what is this line of code doing? It's saying, hey, get the predictions for X test and call them its own variable Y pred. Now we're going to compare Y pred to X test. Now, I mean to Y test. So how do we do it with the mean squared error? So score model with RMSE. I'm going to modify that just so it's to two separate headers. Build XGBoost regressor. And then, okay, first thing we're going to do, so try this. From sklearn, code with me, dot metrics. So metrics are short for scoring metrics. Import. They don't have the root mean squared error, so you have to do the mean squared error. You'll see why we do the root mean squared error in a minute. So once you have it, you can get it. So the MSE is equal to the mean squared error. And then you put in, it's Y prediction versus Y test. Okay. But you really want the root mean squared error. Why? Because if you're computing the distance from a point to a line, like it's the square root of the squares. That's what the Pythagorean theorem is. And what that does, it puts in the same units as Y. This is actually the norm. Why they have RMSE not is beyond me. Anyway, RMSE is basically the MSE to the 1/2 power, 6 square root. And we can see what that is. So we'll print out the RMSE. And we get 55,636. That's actually good. Why is it good? And also, what's this warning? I forget about this sometimes with XGBoost. It says objective reg linear is deprecated in favor of objective reg squared error. If you want to silence that warning, you can put in objective equals, and then in quotes, if you copy the reg squared error. Try that. Oh my gosh, I didn't copy it right. So this is better just to copy and paste, right? Told you guys I'd see some errors from it. Right, and then it just gets rid of the error. So how do I know how good that model is? Well, you've got to go back to Y, right? And just instead of scrolling up, just do it again. Y.describe. And it's not that it's 55,000, it's that how does it compare to the standard deviation? That's the thing to look at. So it's about half of a standard deviation, which is, it's not great, but it's decent, right? Because on average, you're gonna be one standard deviation away. Well, this is better. Okay, this is half of a standard deviation away. So, it's a decent score actually. But that's how you use the root mean squared error. The point here is not, hey, can you be an expert of using the root mean squared error in scikit-learn? We're not going to do that. The point here is that there are different scoring metrics and you need to be aware of that. Okay? So this is going to close out our regression notebook. Let's move on to classification.